Hi class, this is Professor Teixeira. In this video, I'm going to show you how to come up with the optimal order quantity when the supplier offers discounts for different amounts purchased. Okay, so there is discount, prices are different for different amounts. All right, so for this type of problem, the total annual cost is going to be computed summing the total ordering cost, the total holding cost, and the total cost with the for purchasing the units. Okay, let's see one problem and go over that. Here we have VGAGC, which operates its own laboratory on site. The lab maintains an inventory of test kits for a variety of procedures. This company uses 780 A1C kits per each year. So we have here information about the annual demand. Okay, so let me put it here. The annual demand, which is 780 units. 780 units per year. Let's see what else we have. So no, the ordering cost is $15 and the holding cost is $3. So our S is 15 and our H is 3. So here is dollars per order, dollars per unit. All right, so let's take a look. The new price list indicates that orders of fewer than 73 will cost 60 per kit. So let's come up with a table here. Quantity, ordered, and price. Less than 73 units cost $60. That's the unit price. Price per unit is $60, okay? What else? 73 through 144 cost 56. So 73 to 144 cost $56. And orders of more than 144 will cost 53. More than 144 cost $53. Okay. So there is some incentive to buy more, right? Should the company buy more? What the company should do? In this case, determine the optimal order quantity and the total cost. So for this type of problem, we start solving the optimal order quantity as we did before. The optimal order quantity is the square root of 2 times S times D divided by age. So this is equal to 2 times S times D divided by age. And then we take the square root. I use equal SQ or T, this number. So is 88, almost 89 units. Okay, this is my Q. So for this Q, if this is what we're gonna order, how much we're gonna pay? Well, we're gonna pay $56 per unit. Price per unit paid is gonna be $56. So the question here is, how much is my total annual cost if I purchase $56? So let's do it. The total annual cost is gonna be my total order cost, right? My total ordering cost, remember, is my annual demand divided by my Q times my S. So that's equal to my annual demand. Let me put within parentheses. My annual demand divided by my optimal Q times the cost to place orders. My total ordering cost, holding cost, holding cost is gonna be equal to my Q divided by 2 times age, which is gonna be equal to my Q divided by 2 times age. Beautiful, the two numbers are the same. That's how it's supposed to be. So my total purchasing cost. So my total purchasing cost is my annual demand times my cost with each unit. In this case is $780 times 56. So my total annual cost is gonna be equal to this plus this plus this. All the three costs. Let me put in this. $43,944, okay? If I order this amount. So the next step is how much would the total annual cost be if I order the minimum to get this lowest price? How many orders, how many units should I have to order to get $53? What is the minimum that I have to order to get this price? Well, it has to be more than 144. So the minimum is 145. So to qualify for $53, I have to place an order of 145 units. Okay, so let's compute. So here, there is no optimal Q. You're gonna use the table. 145 units is what qualifies. So quantity is 145. Price per unit, in this case, is 53. So my total order cost, okay, is gonna be equal the same thing. Let me copy all this to save some time. Okay. But here I'm gonna replace my Q. My Q here, I'm gonna replace by the quantity times the cost to place orders. Now the holding cost is gonna be my new quantity, equal, open parenthesis, new quantity divided by 2 times my holding cost. You see that now these numbers differ. They differ because I'm not ordering the optimal quantity. The optimal quantity is this. When I order the optimal quantity, the total costs are the same. I'm not ordering the optimal quantity. The costs differ. Okay. Finally, the total cost to place orders, the purchasing cost is going to be the annual demand times my price per unit, 41,000. So my total annual cost is going to be my purchasing cost plus my holding cost plus my ordering cost. So my annual cost here is 41,638, which is cheaper than my annual cost if I order the optimal order quantity. Is because the optimal order quantity doesn't take into account the discounts. Okay, so this is the quantity that minimizes the cost under the discount model. Okay, so this is how much the companies economize the difference between the optimal order quantity and this. So the company is going to save $2,306 if order the quantity that qualifies for the minimum price. Okay, so let's take a look if we can see if we can do one more. Solution 88, 43, 944, 43, 944, using the minimum of 145 kits, 41,000. The company saves $2,306 each year. Okay, that's how we do it. Here is step by step, but I'm assuming that if you read the step by step, you're not gonna do this. That's the reason I'm showing to you how to do it. Let's practice one more time, and let's finish this video. All right, so let me copy some of this information here, kind of save us time. At least this, right? Information are going to be different, but at least saves time typing. Okay. EA Old Shoe Repair has customers requesting leather soles throughout the year. The owner, Warren, buys these soles from the leather company TLC at a price of $8 per pair. So he's paying, that's the cost. So let's put the cost here. Let's keep reading because this cost should be different. In an effort to improve profitability by selling greater quantities, the sales rep for TLC has made the following offer to Old only shoe repair. If Warren orders 1 to 50 pairs at a time, it costs 8. Okay, now we have, let me say it this time too, like doing this, copy, paste here. So if orders how many? 1 to 50, say 1 to 50. No, I want a number. No, 1 to 50. Now let's do this. 1 to 50. Okay, don't joke with me, Excel. $8. Then if it's 1 to 50 units is $8, the price per unit. Okay. What else? If the order is between 51 and 100, is 7.60. So I'm typing this sign here to be able to do 51 to 100, so Excel doesn't come up with wrong stuff for me. So 7.60 and more than 100, right? Then probably it's another price. Orders for more than 100 pairs, 7.40. 7.40. So we have a table here with different amounts and different prices. The owner estimates annual demand to be 625, so the annual demand is 625. Holding cost is 1.6. Holding cost is 1.6. And the order cost is $10. $10. Okay, so how many should the company order each year? Okay, let's do EOQ. So I'm gonna do 2SD divided by age. It will equal to 2 times S times D divided by age. Now we take the square root of this. Square root 880 units. Very similar to the other problem, right? Let me just take a look. Very similar. Numbers are different, but very similar in response. Oh. All right. This is my Q. Okay. All right. So what's my, let me copy here too, the same thing. So we save some time. I can even do this. Let's see if it's going to work. So my price per unit is, in this case, I'm ordering 88. I'm paying $7.6. $7.6. That's the price. My is not doing it. So my total ordering cost is going to be equal to my annual demand divided by my Q times my cost to place orders, which is 10. My holding cost is going to be equal to my optimal order quantity divided by 2, which is the average inventory times age. Beautiful, the two numbers are the same. That's how it's supposed to be. Now the total cost to purchase the materials, so is my annual demand times 7.6. And then this is going to be equal to this guy plus this other two costs, 4,891. So, okay, now quantity ordered quantity. My Q here, quantity. My Q here is going to be the minimum quantity that I qualify for a price of $7.40. So the minimum quantity is 101 units. It has to be more than 100 units. I don't want to order at too many more because this was the optimal order quantity. So I want to minimize the amount I ordered, but to qualify for this price. So my price here is price per unit. In this case, is going to be 7.4. And I always choose the smallest unit price, the cheaper price, and the quantity that qualifies for it, okay? All right, so let me do this to save some. Let me see if I can do this. Let's see if it's gonna work. No. All right, let's do it. So this is gonna be equal to the annual demand, open parenthesis, annual demand divided by this new quantity times my cost to place orders. Then this one is gonna be equal to my average demand, the quantity divided by 2 times the holding cost. You see that these numbers differ, they're supposed to differ. I'm not ordering here the optimal order quantity. And the cost with the purchasing is gonna be this times the price per unit. And then it's, again, this is cheaper than the optimal order quantity. How much the companies economize is the difference between these two values. They economize $123. May not seem much, but any penny in the pocket is a penny in the pocket. Okay, so that's how you compute the discount model. First, do the EOQ, traditional normal EOQ, and then you try the annual cost and all other costs using the minimum quantity that qualifies for the cheapest price. Okay, that's it.